All right, so this is our final project presentation, and we chose to look at the Framingham Heart Study Dataset, which was a study of cardiovascular disease in Framingham, Massachusetts. And so what it did was essentially, it was an observational study that identified various risk factors for cardiovascular disease and perhaps their joint effects and how each risk factor relates to one another. So there are 21 variables, and the majority of them relate to various cardiovascular risk factors such as cholesterol, blood pressure levels, things of that nature. So part of the reason we were motivated to look at this data set was because of the prevalence of heart disease nationwide. So close to half of Americans have some form of cardiovascular disease, and it is the leading cause of death nationally for both men and women. So using the Framingham Heart Study dataset, our research focused on potential associations between risk factors for cardiovascular illness. So we developed and investigated 4 research questions to better understand the impact that various risk factors have on one another. So essentially what we aimed to do was see whether one risk factor coincides with an increase in another risk factor and things of that nature. So our first research question focused on the association or potential association between educational attainment and angina pectoris, which is a symptom of coronary heart disease that's generally denoted by chest pain. So part of the reason we were motivated to look at this is because research indicates that the timeliness of diagnosis is very significant in determining symptom severity and mortality rates for cardiovascular disease. So we believe that, or we thought that the association could exist because the awareness and perception of one's health could be influenced by educational status. So our two hypotheses, our null hypothesis for this research question is that there's no significant association between educational attainment and the diagnosis of angina pectoris. Conversely, our alternative hypothesis was that there is a significant association between educational attainment and the diagnosis of angina pectoris. And the research that we looked at before conducting or before looking at this research question suggested that we should expect an association because health literacy and communication with doctors and various health representatives varies by education level, causing more people with lower educational attainment to go undiagnosed. Next, our second research question focused on a potential association between smoking and cholesterol levels. So smoking and cholesterol and high cholesterol are seen as 2 of the largest risks for cardiovascular disease. Smoking itself is, or over 30% of the attributable risk for heart disease or heart attacks are directly attributed to smoking. So we wanted to see if smoking heightens one's risk for heart disease by increasing cholesterol, or essentially what the reason why, or the reason why smoking increases one's risk for heart disease. Our hypotheses for this question were that, our null hypothesis is that the cholesterol mean levels for non-smokers are the same as the cholesterol mean levels for smokers. And our alternative hypothesis is that the cholesterol mean levels for a non-smoker is different from the cholesterol mean levels for a smoker. So the research we looked at, again, suggested that we should expect an association between smoking and total cholesterol, because cigarette smoking has been shown to contribute to the formation of fat in the heart, which leads to higher total cholesterol. So we expected an association to exist before we actually conducted our research. Our third research question focused on a potential association between age and systolic blood pressure. So we want to look at this because, again, similar to our second research question, each of both age and systolic blood pressure, essentially, there's a positive correlation between each of these and one's risk for heart disease. So age, the older one is, the higher risk they are at for cardiovascular disease. And similarly, the higher one's systolic blood pressure, which is the measure of pressure in the arteries when the heart beats, are both shown increased risk of heart disease. So we wanted, again, to see potentially if the reason why age is associated with a higher risk of cardiovascular disease is because of an increase of systolic blood pressure. Again, our null hypothesis is that there would be no significant association between age and systolic blood pressure, and alternatively, that there would be an alternative under our alternative hypothesis would be that there is a significant association between age and systolic blood pressure levels. Our research that we looked at indicated that we should expect an association because over time, or as one ages, the structure of their heart, arteries, and nervous system, which all contribute to one's blood pressure, change, particularly by stiffening. So the arteries tend to stiffen as one ages, and those cause blood pressure to increase. Our final research question focused on a potential association between body mass index, or BMI, and one's heart rate. So similarly to our second and third research questions, BMI and heart rate are widely accepted as risk factors for cardiovascular morbidity and events. So essentially, the higher one's BMI, which is a measure of one's body fat and obesity, the more likely you are to be susceptible to cardiovascular disease. And similarly, the higher one's heart rate is, the more likely you are to have a cardiovascular disease. Our null hypothesis for this research question is that there is no significant association between BMI and heart rate, and our alternative hypothesis is that there is a significant association between BMI and heart rate. Again, the previous research that we looked at suggests that we shouldn't expect an association because increased body fat leads to greater strain on the heart, which forces it to pump harder and faster to, or more specifically, faster to distribute blood, which increases one's heart rate.
Now talk about the variables of interest. For our research question 1, we have attained educational level as our categorical explanatory variable, and there are 4 levels of it: less than high school diploma, some college vocational school, and college degree or more. And we have angina pectoris as our dichotomous categorical response. For research question 2, we have whether or not an observation is a smoker as our dichotomous categorical explanatory variable. So obviously there's smoker and non-smoker. And we have the serum total cholesterol level as our numerical response variable. For research question 3, we have age divided into 3 levels as our categorical explanatory variables. And the recorded 3 levels are 41 to 55, 56 to 70, and 71 to 85. And we have our systolic blood pressure as our numerical response variable. For research question 4, we have body mass index as our numerical variable, explanatory variable, and heart rate as our numerical response variable. So every question requires recoding procedures in our project. For question 1, we have the highest educational level attained recoded. It was originally a categorical variable with empty cells. So what we do is to create a new recoded variable to replace the empty cells within it. And by creating the new recoded variable to replace the empty cells within it, we could eliminate the effect of empty values on our statistical tests. For question 2, we recoded the current cigarette smoke at time of the exam. So it was originally a dichotomous categorical variable, and the 0 represents not current smoker and the 1 represents current smoker. So we created 2 new recoded variable non-smoker to represent the cholesterol level of not current smoker, and smoker to represent the cholesterol level of the current smoker. So by creating the new 2 recoded variables to replace 0 and 1, we can conduct a 2 sample t-test to see if there is a difference in the cholesterol level between current smoker and not current smoker. For question 3, we recoded the age. It was originally a numerical variable, and we created a new recoded variable to divide the age into 3 categorical variables. And they include 41 to 55, 56 to 70, and 71 to 85. So by dividing the age into 3 categorical variables, we can compare if middle-aged, middle to elderly age, and elderly groups have significant difference systolic blood pressure. Through this, we could decide if systolic blood pressure has any association with age. And for question 4, we recode the BMI, which is the body mass index. It was originally categorical variable with empty cells. So we first create a new variable to replace the empty cells in the original variable within it. And then we create another numerical variable to convert the original variable into a numerical one. And then we check the outliers and create a subset BMI clean without the outliers. So by creating a new variable to replace empty cells within it, we could eliminate the effect of empty values on our statistical test. And then we need to convert it to a numerical variable for checking the outliers. And after that, we need to create a subset without the outliers to conduct linear regression. So for question 4, we also recode the heart rate in the same method because it was also originally a categorical variable with empty cells. We again first eliminate the empty cells and then convert it to a numerical variable to conduct linear regression. So for the statistical tests we use for question 1 is chi-square test. For question 2, it's two-sample t-test. And for question 3, it's ANOVA test. And for question 4, it's linear regression. So this is our plot for research question 1. So as you can see, we cannot really tell difference from the plot. So we decided to conduct a chi-square test. For our test assumptions, so first of all, obviously, all the observations are independent and all the expected cell counts are greater than 5, so we can conduct the chi-square test. The results, the tested statistic for chi-square test is 55.303, and the p value is obviously significantly smaller than 0.5. So our chi-square test results indicate that there is an association between highest educational level attained and genome pectoris diagnosis. Thus, we can reject the null hypothesis. The individual's probabilities of being diagnosed with angina pectoris are associated with their highest educational level attained. And according to the observation, those with a college degree or without a high school degree are more likely to be diagnosed with angina pectoris than those with a high school degree or with some college experience.
So now let's move to research question 2 plot. Our research question is about cholesterol level by smoking or not. From this box plot, you can see that the mean of non-smoker and smoker is pretty close to each other, the mean cholesterol level. And let's move to the two-sample t-test results. Our N is 8,090 because some of the cells are empty, and our t statistic is 5.2318 with a p-value significantly lower than 0.05. The mean of the non-smoker is about 238.4, and the standard deviation for non-smoker is 44.6. The mean for smoker is 233.2897, and the standard deviation is 43.9. From the previous t-test, we can indicate that the new hypothesis, there is no difference between the mean cholesterol level of smoker and non-smoker should be rejected since the p-value is lower than 0.05. So it is to say that the mean cholesterol level of smokers is lower than the mean cholesterol level of non-smokers. And this is our research question 3 plot, which we have 3 age groups. We can see that the mean systolic blood pressure has an increasing trend as the age increase. So we performed a ANOVA t-test with N equals 9,094, and the F value is 486.7, and our p-value is also lower than 0.05. Our residual is 9,091. So the result from the ANOVA t-test, the ANOVA test indicates that the null hypothesis, there's no difference between the mean systolic blood pressure level across different age groups should be rejected. There is an increasing trend. So the mean systolic blood pressure level has a positive correlation with age. You can see that there is an increasing trend of each age group. So we create a scatter plot for research question 4 to show the correlation between heart rate and BMI. The independent variable is BMI, and heart rate is the dependent variable. we can see that all the data are pretty scattered and there's a really low correlation. We performed a linear regression test with n equals 9,094. We found out that the correlation between heart rate and BMI is 0.0489. And we're 95% confident that the true correlation between heart rate and BMI falls between 0.028 to 0.069. Our intercept is 73.28594 with a p-value significantly lower than 0.05. Our BMI correlation is 0.15088 with a p-value that is also lower than 0.05. Our R-squared is a 0.002393 and our F statistic is 21.73. So our ANOVA test shows that there is a low but significant positive relationship between BMI and heart rate because our p-value is lower than 0.05. We can reject our new hypothesis that there is no correlation between BMI and heart rate, and our predicted equation is predicted heart rate equals 73.28597 plus 0.049 times BMI.
All right, so now to quickly discuss just an overall summary of our results. In our first research question, we found that people with higher educational attainment are more likely to be diagnosed with angina pectoris than those with less. In our second research question, we found that there is an association between smoking and cholesterol levels. However, it differed from our expected results as the mean cholesterol levels of smokers was actually lower than that of non-smokers. Our third research question found that systolic blood pressure is positively correlated with age. So people with older age groups have higher systolic blood pressure levels than those in younger age groups. And our fourth research question found that a relationship also exists between BMI and heart rate, though the correlation is relatively low. It does conclude, however, that people with higher BMIs are more likely to have higher heart rates than people with low BMIs. So overall, our results indicate the ways and various risk factors of cardiovascular disease relate to each other. As a result, in terms of significance, our findings can be interpreted as a mechanism, or people can use them to as a way of mitigating or improving one's awareness for potential susceptibility to cardiovascular illness. For example, older and more obese people should be wary of their exposure to heart disease, as our findings indicate or associate age and BMI with cardiovascular risk factors. However, the results for our second research question are interesting, as it differs in terms of what, or at least in terms of usefulness as a means of mitigating risks to cardiovascular disease. Because although we found that non-smokers tend to have higher cholesterol than smokers, smoking is widely considered to be one of the largest risk factors of cardiovascular disease. As a result, our research question should not be used as a means of telling people to smoke to lower their cholesterol. Okay, now discuss potential limitations of our research questions. So some of the observations did not have responses for an angina pectoris diagnosis, which could skew the results of our first research question. And then furthermore, the graphs for each of the various age groups, when we split the age groups into three different groups for when we were analyzing the association between age groups and blood pressure, were significantly right skewed, which calls into question the validity of the ANOVA test and also increases the likelihood of a type 1 error. And lastly, and probably most importantly, when we're looking at studies that relate to heart conditions or really any medical conditions, confounding variables such as pre-existing conditions, geography, there are a number really, can contribute to each of the response variables analyzed. So while our results imply that an association exists within every research question, it's possible that the associations may stem from an additional unknown factor. And so these are just potential limitations, and that concludes our presentation of our final project. So thank you.